Hi everyone, I am Gajendra Kane from Sri Venkateswara College of Engineering. I am going to explain about the subject is network analysis in the topic superposition theorem with problem solving. Superposition theorem. See the contents on this topic. Contents: Introduction, theorem statement, procedure for superposition theorem and problem for example. Let's see the introduction on this topic. Introduction. Superposition is based on the concepts of linearly between the responses and execution of an electrical circuit. It states that the responses in a particular branch of a linear circuit when multiple independent sources are acting at the same time is equivalent to the sum of the responses due to each independent source acting at a per time. Superposition theorem statement states that in any linear and bilateral network or a circuit having multiple independent sources, the responses of an all elements will be equal to the algebraic sum of the responses of that element by this considering one source at a time. How to solve? There is a five steps. The first step is select one among the multiple sources present in the bilateral network among the various sources in the circuit. Any way of the sources can be considered first, except for the selected source. All the sources must be replaced by their internal impedance. Next point. Using a network simplification approach, evaluate the current flowing through the or the voltage drop across a particular element in the network. Next point. The same considering a single source is repeated for all the other sources in the circuit. Upon the obtaining the respective responses for individual sources, perform the summation of all responses to get the overall voltages drop or current through the source element. Let's see the example or problem on superposition theorem. Problem. Find the current flowing through 20 ohm resistor of the flowing circuit using superposition theorem. We can see on the screen that circuit contains voltage source and resistor and current source. Now let's see the solution on this topic. Solution. Step 1. Let us find the current flowing through 20 ohm resistor by considering only 20 volt voltage source. In the case, we can eliminate 4 ampere current source by making open circuit of it. Its modified circuit diagram is shown in the figure. We can convert it into the current source into voltage source. There is only one principal node except ground in the above circuit, so we can use nodal analysis method. The node voltage V1 is labeled in the following figure. Here, V1 is the voltage from node 1 with respect to ground. In this figure, we have to see V1 is the node. We can apply the analysis or nodal analysis of the node voltage 1 V1. The nodal equation at a node 1 is V1 minus 20 divided by 5 plus V1 divided by 10 plus V1 divided by 10 plus 20 is equals to 0. Your 6 volt minus 170 plus 3V1 plus V1 divided by 30 is equals to 0. The V1 is equals to 12 volt. The current flowing through 20 ohm resistor can be found by doing the following simplification. I is equals to V1 divided by 10 plus 20. Substitute the value of V1 in the above equation. I1 is equals to 12 by 20 plus 10 is equals to 12 by 30 is equals to 0.4 ampere, means source, current source. Therefore, the current flowing through 20 ohm resistor is 0.4 ammeter. When only 20 volt source is considered. Step 2. Let us find the current flowing through 20 ohm resistor by considering only 4 amps current across. In this case, we can eliminate 20 volt source by making a short circuit of it. The modified circuit diagram is shown in the following figure. In the above circuit, there are 3 resistors to left of terminal A and B. We can replace those resistors with a single equivalent resistor where 5 ohm and 10 ohm resistors are connected in parallel, and an entire combination is series with 10 ohm resistor. The equivalent resistance to the left of terminal A and B will be A or B is equals to 5 into 10 divided by 5 plus 10 plus 10 is equals to 10 by 3 plus 10 is equals to 40 by 3 ohm. The simplified circuit diagram shown in the following figure. We can see the circuit. We are converting 40 by 30 ohm. We can find the current flowing through 20 ohm resistor by using current division principle. I2 is equals to Is by R1 plus R2. Substituting Is is equals to 4 ampere, R1 is equals to 40 by 3 ohm, and R2 is equals to 20 ohm in the above equation. I2 is equals to 4 into 40 by 3 divided by 40 by 3 plus 20 is equals to 4 into 40 divided by 100 is equals to 1.6 ammeter. Therefore, the current flowing through the 20 ohm resistor is 1.6 ampere when only 4 amps current source is considered in this problem. Step 3. We will get the current flowing through 20 ohm resistor of the given circuit by doing the addition of two currents that we can got in step 1 and step 2, mathematically it can be written as I is equals to I1 plus I2. Substitute the values of I1 and I2 in the above equation. I is equals to 0.4 plus 1.6 is equals to 2 amps. Therefore, the current flowing through 20 ohm resistor is given by is a 2 ampere. Thank you.